All right, so today we're going to continue, or actually we're going to conclude with object-oriented programming by summing everything up with the solid principles. The solid principles it's just an acronym for 5 different principles that are essentially a restatement of all of the 4 pillars that we've talked about before of good encapsulation, abstraction, polymorphism, etc. If you remember that we are online, so if you have any questions, go ahead and post to Piazza or for the YouTube chat. The solid principles are, SOLID. It's an acronym. Each one is a different principle. The S stands for responsibility principle, right? And that just simply means that you have good encapsulation. That a class should represent one thing, right? And represent it well, right? You shouldn't have a mixture of responsibilities. For example, don't have God classes, right? You shouldn't have a class that does everything, sees everything, is everything. A person class, for example, right, relevant to your project here, a person class should be responsible for person things, right? An address class should be responsible for address things, right? It's not saying that a person doesn't have an address, but you shouldn't conflate the two. You should have a separate address class, like we did in class when we did products, I think, or something like that. Or students or something. I forget what it was, but if you take the 5 things that make an address and you put it in the person class, you've conflated these 2 objects. There certainly is a relationship. Through composition, a person owns an instance of an address, but by putting all these things together, then you violated the single responsibility principle, and you violated good encapsulation, right? This also goes into the DRY principle. Don't repeat yourself, right? Other things could have an address, right? A property, a real estate property could have an address. A manager could have an address. A store could have an address. And if you've properly created an address class, that means it's reusable all over the place. And you don't have to repeat yourself. You don't have to take these same 5 things and cut and paste everywhere. Anytime that you have a real world entity that you need to model, it should be screaming out to you, put me into a class and treat me like one thing, okay? You can, of course, go overboard, and we saw that in a couple of submissions, thinking that like a person is a name, an address, and emails, and they made a name class, and that name class had a first and last name. That's going a little bit too far. That's a YAGNI, right? Remember the YAGNI? You ain't gonna need it, right? A name, a first name, and a last name, that really only tells me that that's a person. A person would only ever use that. If you don't have any use for it outside of that class or potential reasonable future use for it, you don't need it, right? Don't do it. Yeah?
Yeah, I did that. Is it too late to change it back, or do I need to?
I don't think we took off for it, but they're still in grading. Yeah, you probably want to refactor that.
Right.
You're going to really want to refactor that when you get to the database level, because that requires you then to have yet another table. And then there's a one-to-one relationship. And when you have a one-to-one relationship in tables, why do you have 2 separate tables, right? It's not like John Smith is going to be, certainly there are multiple John Smiths out there, but you create this class just for John Smith so that these 3 John Smiths over here can use it. No, right? Don't do that. This also goes into avoid what are called leaky abstractions, right? So good encapsulation also means that you close off responsibility, that the outside world shouldn't have to be responsible for the internal workings of a class. Now, again, we didn't take off for this, but for example, suppose design A, right? That a person owns a list of strings, which are emails, right? Which is provided at instantiation. Think about that design. Right? In other words, when I'm parsing out the file, I have now to create a person, I have to create this list of emails, and then I give it to the constructor, right? Now, think about this as design B, right? A person has an add email method. Which one of those designs seems like a little bit better than the other? I mean, you could say that, you could argue about it and say that they're equally good or equally bad or whatever, right? But tell me about what are some advantages of the second one? That you could just add an email, right? And does it require me to know that it's a list? The internal workings of the class represent their emails by a list? Nope. What if they changed it to a set? Now that forces the client code to change their behavior based on the internal workings of another class, right? Whereas that second design, does it matter if it's a set or list? Nope. Just add emails. I'll take care of it, right? You don't have to know that it's a list or a set or a map or something else entirely. You give me your string and I'll take care of the details, right? Which one is easier to use? Probably the second design. The first one is a leaky abstraction because we've leaked out information about how we're representing the emails. We're representing it as a list. We're representing it as a set, right? We leak out that information, forcing the client code, whoever uses our class, to conform to that one particular way, right? Whereas if we had just had an add email method, we can change the internal workings of the class and not break any of the client code, right? Any of the code that uses it. The solid principles also extend, say, to your project. And this is something we did take off for. Consider your current project phase 1. Right? You're doing a couple of things. You're loading data. Right? You are persisting, saving. That's just a fancy word for saving. Persisting or serializing. Serializing as JSON. Right? What else are you doing? You're persisting or serializing, persisting as XML. Right? How many things does that sound to you? How many responsibilities does that sound to you? 3, right? So how many, certainly you should have at least 3 functions to do it. But now that we're thinking in terms of objects, how many classes do you think you should have? Probably at least 3, right? Now you can go overboard, Yagni, right? You can over-engineer it and say, I'm going to define an entire inheritance hierarchy for a data parser, a data loader. And then I'll subclass that for assets. I'll subclass that for persons. And now that we're getting into accounts, I'll subclass that for accounts. You can do that, but that's going a little bit far. Yeah, you ain't going to need it, right? But certainly you should have at least had 3 classes here, maybe 2 classes if you wanted to say loading data and then persisting data. But XML and JSON are 2 different things, right? Think about futurizing this code. Suppose that we now require a third serialization form, a binary serialization form. What are you going to have to do now? Add methods to the same class versus just create a new class and don't worry about changing the code that already works. Right? Extending the behavior rather than modifying the behavior. Think ahead even to this project. You're loading up from CSV files right now. What if you loaded up from XML files instead? Or something that you will be doing, you'll be loading up from a database instead. Right? Does that mean that you're going to go back, delete everything, and modify it? Or if you had it in a separate data loader class, you can create a brand new data loader class that loads from database, a data loader class that loads from CSV, a data loader class that loads from XML or something like that, right? Separating those things out into separate classes means that you don't have to go back and muck with your the current code base. So that sounds like 3 things. Make sure that everything has a single responsibility so that you're not making these God classes or demigod classes if they're doing a little bit, right? All right, questions on S of solid yet? Yeah, go ahead.
For things like that you didn't take points off, like the Yagni or the key abstractions, are they also mentioned on the code post or where?
I mean, all the feedback will be available on code post. Yes.
Okay.
right? And then, of course, we'll have our usual retrospective.
Okay.
On the retrospectives, I write it for the main section, even if, I post it here as well. There are fewer of those problems, so when I say common problems, they may not be so common for the honor section, but I still mention them so that you're aware of them. Right? The O stands for open-closed principle, and the idea here is that every unit of code, whether it's a module, a class, or a method, or whatever, should be open for extension but closed for modification. And all this is classical inheritance. That you can should extend specialized behavior in subclasses without having to modify behavior in the superclasses. Right? So in general, in subclasses, you can add methods or variables, but you should not break things, right? And what I mean by that is consider the following scenario. Suppose you create a general class with some functionality, right? And 5 subclasses all use that functionality, right? Now, suppose that you have a new class, right? That subclass, a new subclass, I should say, right? That needs to do things differently. Should you modify the behavior in the superclass? What if you did? What would you do for those 5 other subclasses that depend on it? You'd break them all, right? Don't do that. That's why the superclass should be closed for modification. Once you have defined a hierarchy in your inheritance and you've defined some sort of functionality up here that other things depend on, if you go messing with that if you go mucking with the functionality up here, that permeates all throughout your entire hierarchy, right? So have a well-defined hierarchy to begin with, have a well-defined generalized behavior, but then make sure that you don't touch it. Make sure that you close it for modification. One of the classic examples is the integer class. Recall, the integer class is final. Why? It's completely closed for modification. Why would you ever want to modify what an integer is? Would you want to redefine addition to subtraction? Would you want to redefine an integer so that it could be 3.5, right? No. There is the ultimate closure for modification. We're not going to allow you to subclass it at all, right? Other methods can be made final to prevent or completely close off a modification, right? Etc. If you need to provide specialized behavior, make sure that you're doing it with an extension, like a subclass, and that you're adding on to that behavior. Don't go mucking with something up higher, further up in the hierarchy. And that's why having that kind of that inheritance thought out and well defined to begin with is so important. Because once you've created that inheritance and you start writing code that depends on that inheritance and depends on that functionality, that's it. Unless you go throwing away everything and starting from scratch, then you start to break things. Okay. If there is no well-defined behavior, general behavior, make things abstract, and force subclasses to define them. For example, I don't know how to, like if we have a general item in our store, I don't know what the cost of that is. It depends. Is it a product? And so it's quantity times price per item. Is it a subscription? And so we have to consider the start date and the end date and times an annual fee, et cetera, right? If there is no well-defined general behavior, then don't define it. In general, think about what is universal behavior, and close it for modification. Right? think about specialized behavior and make it possible to extend it. What about our project? Or actually, more recently, think about Lab 5. What was one universal? Yeah, Lab 5 was the payroll system. What about get taxes? Does that change depending on if they're hourly employee or salary employee? Oh, I don't think it did it? It was just
like
gross.
15%, was it 20%?
The rate was, but your math is universal. Gross times rate, right? Tax rate.
Oh, yeah, that right. So we can change
That's it. So that you can change and the specialized behavior of tax rate in the subclasses, right? What about that's universal, and should be closed for modification. But like if you go changing how taxes are there might be some more complicated rules or something like that. But that one particular lab, that was not changing, right? What about specialized behavior? The actual rate, or what else? Get gross pay, right? The actual rate, one half of this equation or the other half of the equation, they were both specialized behavior that you provided in the subclasses. And so you made that extendable, you made it open for modification, right? Open for extension. Yeah.
So when you make a method final, people can't override it, or subclasses can't override
Exactly. If you make the class final, nobody can can subclass it at all,
it.
like integer. There's a very, very good reason that you would not want somebody to subclass an integer, right? Okay. What about your project? What is one thing that is universal there? Or what's one thing that is not universal then? Specialization. Okay. An exchange fee on cryptocurrencies. All right. Think even higher than that, though. The value of an asset to begin with, right? The value of an asset. It is completely different if it is a property versus a cryptocurrency versus a stock versus an option, right? But what is something that is generic or general, right? Gain or loss. Right? It doesn't matter what it is. It has value, and it also has some purchase value, right? And if you purchase $10,000 of Google stock one day, and the next day it's worth $20,000, you made $10,000. If you bought a house for $100,000 and then 3 years later it's worth $200,000, you made $100,000, right? It's just the origin price minus the current price, or current price minus the origin price, or purchase price, etc. Right? The gain or loss is universal. Right? So we should probably close that off for modification, right, in our design, or at least not go and changing it once it's established. All right. That's the O. What about the L? The L is actually named after an individual, and I'm going to go ahead and cut and paste this. Barbara Liskov. In fact, I put in the optional viewing or whatever, I hope it's still a live link, but she explains the history of how the Liskov substitution principle came about. Of course, she didn't call it my substitution principle. Other people called it for her. But basically, it's that if S is a subtype of T, then objects of type T may be replaced with objects of type S without altering the desired properties of T. And that's simply just, subtype polymorphism in practice, right? They actually had to come up with the math behind it to explain it. But it's kind of like have you ever heard of Principia Mathematica? Right, it's Russell and Whitehead, I think. It's this big giant book, establishing the axioms of mathematics. So the joke is that it took 500 pages to establish the math to prove that 1 + 1 is equal to 2. Right? You need that much. You basically need the language in order to start talking about simple things like that. And so they needed the mathematical language to formulate this idea. And it all simply comes down to subtype polymorphism. If I have a list of integers, numbers, right? I can set that numbers equal to a new array list, right? Or I could set numbers equal to a new numbers equal to a new linked list. Right? Remember, those are two different types of lists in the collections hierarchy here. An array list holds stuff in an array, and a linked list holds stuff in, as we'll see later on when we actually implement our own. The first one is at this node, and this node has a reference to the next node. That node has another reference to another node. It's linked together like this big giant chain, so that you don't have to have an array under the hood anywhere, right? But the Liskov substitution principle says that if I have a list, it doesn't matter if it's an array list or a linked list, nothing breaks, right? And if something did break, that would be a violation of this principle. We've seen that, right? Recall the rectangle square problem. What was the problem there? Is a rectangle a square? Not necessarily. Is a square a rectangle? Yes. But what if I take a square and change its properties? So instead of a 10 by 10 square, I have a 10 by 20 square. That's not a square. But the object is still a square, right? It's just that it's violating what it says it is, right? So you need to make sure your objects are in a well-defined hierarchy so that properties do not contradict the semantic meaning of the object, right? By creating a 10 by 20 shape that is that's its type is a square, we're violating what it means to be a square. What about your project? Hopefully you've read ahead, because that is part of this week. You need to be producing your design document. How many option types are there? Two. Okay, good answer. Why do you say two? A what? Oh, okay. So a so one answer would be two: a put and a call. All right. Okay. Are there different types of puts and calls, though? Let's just focus on a put. What kind are there? Short and long, right? So maybe another answer would be four, right? Where you've got short calls, long calls, short put, and long put, right? But now think about this. What does it mean for something to be long or short? The strike price and the current price. And the current price, guess what? Fluctuates, goes up and down. So if depending on if it's a call, if it's a put or a put or a call, right? If the price is greater than your strike price, you make money. If it's lower, then you lose money, right? In other words, the price changes whether or not it's long or short. So what if we did create four subclasses? We made a short call, but then the price of the stock changed, making it into a long call instead. Violation of the Liskov substitution principle. That's why I like your answer of two, right? Whether or not it's long or short depends on the state of the object. Yeah.
So do we have to do all four of the asset types, or
well, what do you mean all four?
Because like I think in assignment or project overview.
Crypto,
right.
stock, property, and options.
You have to do three of them.
At least, yeah. Yeah.
You have to do all four, because like you for honors bonus is required.
Well, no, I mean this has nothing to do with honors. You have to model all four,
Okay,
right? Yeah, and how you put this into your hierarchy, there's multiple okay answers, right? There are some obviously bad answers, right, that violate Liskov substitution principle and others.
Are we supposed to put, because in assignment 2 we only did crypto, stock, and assets.
So now you have a new one, right? Did your design allow it to be open for extension? If not, you might need to go back and fix it. And whether or not you put options into a hierarchy or use composition or something like that, again, there are several okay designs around that. Right?
So we will be adding options into
Oh yeah, right. The reason we didn't put that in the first assignment or in the first phase is because an option is an option to buy a stock at a certain date, and that only happens when it's on an account, right? Okay, all right. So there's the SOL now. That's another acronym, but anyway. Interface segregation principle, I of solid, right? So the statement here is that no client code should be forced to depend on methods that it doesn't care about or that it doesn't know how to implement, right? So for example, suppose that I'm doing a graphical user interface program and I need to register a click event handler, right? So that when you click that save button, it goes and saves the file. And I write the code that saves the file to disk or whatever, puts it up in the cloud, et cetera, et cetera. But suppose that was an interface that defined two things, an on-click event and an on-double-click event, right? So it should be clear that on click, I'm going to save the file. What happens on double-click? Right, when somebody, when some grandmother type, double clicks everything. If you ever see somebody, surfing the web, and instead of just single clicking a link, they're always double clicking everything. Double click, right? What do you do? Yeah, I don't know. I don't want to do anything, but by having this event click handler interface, I am forced to implement both of these. Right? So what's one workaround? How do you, if I have this design and I'm forced to implement the on double click event, what's one way that you could handle that?
Just call on click.
Call on click. So treat all double clicks like they were clicks. That's one way. Another way is don't do anything, right? Or another way is throw an exception. This is not supported method, right? And then let the chips fall where they may, right? It's kind of similar to checked exceptions. So remember that checked exceptions are ones that you are forced to surround with a try-catch, even if you don't want to. There's no way that I can recover from the file not being there. There's no way that I can recover from the bad password or something like that. But this bad design of checked exceptions has forced me to deal with it, even if I have no preference for how to deal with it. Likewise, if I've defined two methods here and I only really want to implement one, then I'm forced to deal with some hackish way for the second one. Call the other function and conflate a click and a double click event, or throw an exception, or do something, right? I shouldn't be forced to do that, right? Forcing a user, that is a programmer, to do something or do something in a specific way is far less flexible. So we want to segregate our interfaces. In other words, we want, in general, interfaces should be kept as small as possible. Right? 1 or to 3 methods at most. Right? In fact, if we look at an example over here, the collections hierarchy again, this has very, very segregated interfaces. Now, that means that we have more interfaces, but that also means that each interface only defines a little piece so that we can mix in what we want and leave out what we don't want. For example, if I look at list, I see all of these known, let's see, that's the interface. Let's go with, is there an array list? Where are you? There we go. Let's look at an array list. And let's look at all of its implemented interfaces. Serializable, clonable, iterable, collection, list, and random access. Right? Serializable does not even define a method at all. It's 0. You can't get much more segregated than that. You can't get any more minimal than that. right? Why do we have it then? It adds properties to this class. We're making a promise. I promise that this class is serializable, that I've done something in some way to make it serializable. Likewise, clonable. No methods here at all. Yeah.
So it has nothing in it.
No, it's just giving semantic meaning to it. That this thing is clonable. I'm not defining how it gets cloned because that's actually defined in the object class. There's a clone method, right? I'm just saying, I promise I have implemented that. I'm not just using whatever default behavior that I've gotten from the object. Right? Something a little bit more substantial here would be iterable. This was what makes a collection that you can put it into a for each loop, an enhanced for loop. Right? Now, old school Java, there was only one method. In Java 8, they added 2 more methods for more functional style stuff, but they're still keeping it small. Right? Now, the collection and the list interface, those are going to have many, many more methods. But they're all very, very specific to that list or that array list or that collection. So those are not small, but they're well defined and they're well designed. Later on, your last phase of your project, you're actually going to make your own list implementation. And you might be tempted at that time to say, I'm going to go ahead and implement the list interface in Java. Well, guess what you've committed to? You've committed to implementing every single one of these methods and every single one of these methods. Right? So, good idea, bad idea? I'll leave that to your own design decision. Right? Do you want to implement all of those methods, or do you want to segregate everything out and only implement the ones that you care about? Right? That's what's behind the interface segregation principle. Random access also does not define any method at all. Right? It's just saying that you can use the get method here, and it doesn't cost you anything, or it costs you a constant amount of resources. Okay. All right. Another example. This is a simplified version of Lab 5 where we had that payroll system. And I segregated out these 2 interfaces so that I could be judicious about what is a person. Well, an intern is a person and an employee is a person. But a supplier is not a person. Who is payable? Employees are and suppliers are, but not interns. Right? Imagine if I'd put this into one big interface. Right? I don't know what it would be called, payable person or something like that, personable payment or whatever. But if I had done one interface, then that means I would have forced suppliers to also be people. In other words, have a get first name, get last name. I would have forced interns to become payable. And how would I have dealt with that if I didn't want to pay them? I'd have to implement a method just simply to return 0. Right? No, don't do that. Segregate your interfaces. Right? Loaded word there, but maybe interface separation principle is much better. Right? But whatever. Right? All right. When designing an interface, keep them as simple as possible, 1 to 3, or no methods at all. This last one is also a misnomer, dependency inversion principle, because it doesn't actually invert anything. Yeah.
So, for like blank interfaces, is it up to the class that implements them to do whatever they say to do?
Mm-hmm. It's a promise, right? For example, where was that random access? So the random access is an array list has random access, but you'll see here that there is no ... down to linked list because you don't have random access, right? Random access means that if you want the 5th element, right, then you know to go over 4 times however many bytes are in that element, and you can immediately jump to that memory location. Right? You can't do that with a linked list. That this node might be here in memory, and then it points to that other node in memory, points to that other node in memory, points to that other node in memory, and so to actually get to the 5th element, you have to go 1st, 2nd, 3rd, 4th, 5th. 5 operations instead of just jump there. Right? We'll get into that when we talk about efficiency and linked lists and array-based lists. Right? So the dependency inversion principle says that high-level modules should not depend on low-level modules. Right? Instead, and this is why I don't like inversion, because you're not inverting anything, both should depend on abstractions. And for that, I get to start drawing some pictures here. You'll find that I'm going to bring my iPad more and more as we get into more, of these conceptual ideas instead of code-based ideas, right? So here's my high level, and here's my low level, right? Here's a high level, and then we've got a low level thing, right? Module, class, method, whatever you want, right? And we've got this dependency, depends on, right? So now think about if I want to change out this low level thing, right? For example, it's a library or something that my code depends on, math library. And now a better math library comes along, right? An alternative. And I want to change my code so that it doesn't depend on this one anymore. I want to sever that connection and make it depend on this one now, right? Low level B. What do I have to do conceptually? All of my code up here, guess what? Changes, right? And I'm now I have a new dependency, right? The picture should instead look like this. Here's the high level, right? Here's the low level, say A, B, or C. Right? We have 3 competing libraries or something. And what I do is I put something in the middle. That something is called an interface, just like we've been talking about here. And now this high level will depend on this interface, and each one of these lower level items will implement that interface, right? And I've severed the connection between the high level stuff and the low level stuff, so that what if I want to change out from library A and now I want to throw that out and now I want to use library B? Do I have to change anything over here? Nope. Because this one implements this interface, this one, it relies on that interface. I've got this thing in the middle now, right? And again, it's not an inversion at all. It's not like you're taking and you're putting the low level on the top or something. You're inverting the picture. You are actually making everything onto the same level here. Right? Let's take a look at a more concrete example, but it's still a made-up example. Let me go over here to my code notes again. Right? All right, so suppose that we have an app on a phone, and it needs some geolocation stuff. And we've got this, this one library that's a GPS locator that gets the latitude and longitude in degrees, right? Degrees. Now, remember that latitude is on -90 to +90. Longitude is on -180 to +180, right? So these are numbers that we get back that tell you where you are on the planet. Now suppose that there's library B. Library B actually is an Android library. And it's you can get the location, but it gives you this other Android location object. And then from that, you can get the latitude and you can get the longitude. And there's this third library, C, that actually improves the accuracy by going to cell phone towers and triangulating your position, right? So it can get down to within I think GPS is within what, 10 meters, 20 meters, something like that. And cell phone towers, if you triangulate, you can get to within a meter or something. I don't know. Anyway, they've got latitude and longitude, but instead of degrees, they're in radians. 3 different libraries, 3 different ways of interacting with them. If I did not have dependency inversion, my code might look something like this. If I'm using library A, then I will create a new location. If I'm in library B, I'll create a new location. If I'm doing library C, I'll create a new location, right? One universal location, but how I create that is different. With library A, I have to go to gpslocator.getLatitude. For library B, I have to get the location, which is an Android location, and then I have to get the latitude and longitude. For library C, I have to call radians to degrees once I get the latitude and longitude, and convert them to degrees, right? Now suppose I have a new library D. What do? Else if, right? I guess I need some. There we go. Now it's syntactically correct, even though it's fake code still, right? Library D, library C, right? What if library A becomes deprecated and I want to remove it entirely, right? I have to come in to the client code and remove it, right? Whereas, what if instead the picture looked like this, where I've got my app and I've got my interface, right? That says simply just get location. And then I've got my 3 libraries over here, A, B, and C. And then maybe I have what's called a thin wrapper class that takes care of all that logic for me, but in 3 different classes. Right? This is an adapter. It adapts whatever is in these libraries and then translates that to my location instead of an Android location or just 2 numbers, right? And then each one of these implements, right? And then we only rely on that interface. And we never have to change any code here going forward no matter what. New library comes in, well, that's just a new wrapper class. Old library gets swapped out, who cares? We didn't have to change any code over here. We just had to delete that class, right? Loose coupling is what this is. Loose coupling. Right? We couple things together, right? We make 2 components coupled together, joined together, but it's loose so that we can break this connection, bring in this other thing over here, and recouple it. Yet another example as far as your project is concerned. For each one of these, I try to relate it to your project. This one will come on later on. You will eventually have your project data or your project code up here. Right? And you're going to have to start reading from a database instead. Right? Anybody know any databases? Okay, MySQL. Right.
SQL is a language.
SQL is a language, right? Structured query language. Right? Any others? No? SQL Server?
Oracle, is it?
Okay, Oracle. Technically, MySQL is owned by Oracle. It's the free version. Oracle databases are quite expensive.
It's like big company.
Yeah. It's Oracle owns MySQL, but also Oracle has their own Oracle database that's free, millions of dollars, right? Potentially millions of dollars. This is a few hundred, maybe 1,000 or something, depending on, I don't know. I haven't priced out Microsoft in a long time. Right?
Is Oracle better than them?
No, not necessarily, right? It depends on how much money you have, right? So there's also, here's another acronym for you, CYA principle. Right? Anybody know what that is? Cover your ass, right? So you are in charge of a mission critical database system, right? For example, all student records in the entire university system. You could build something sitting on MySQL, free software, right? You could do it cheaply, but when something goes wrong, who's to blame? You and only you, right? Now, if you use an Oracle system that you're paying them millions of dollars, et cetera, and something hits the fan, guess what? Oracle is responsible, right? That goes into the CYA principle, right? So maybe sometimes millions of dollars is worth it because it's not your neck on the line. And also, you can sue them, or you can take them to an arbiter for breach of contract or something like that, right? Et cetera, right? It's not a matter of who's better. It's a matter, there's way more other things that come into play then, right? But let's think about loose coupling here. What if I took my project code and I programmed it specifically only to connect to a MySQL database? But now instead of 100 users, we've got hundreds of thousands of users, and we need to scale up. So we need to migrate over to an Oracle database because now we can afford it, right? Well, guess what happens to all my project code? Throw it out, and now we're dependent on Oracle, right? Rewrite it all for Oracle. That's too expensive, all right? Rewrite it again so that we're using SQL Server instead, right? Something in between. Forget that. We'll go ahead and go with a Postgres. Free and also very, very good, right? Now, each time we had to throw out our code. Whereas if we had our project code over here, and it depended on some sort of interface, and each one of those companies, Microsoft, Oracle, or whoever, Postgres, right? They published what are called drivers. And then we simply plug that driver in that implements this interface. Since we program towards the interface, we don't know anything about what's going on under the hood over here, right? Abstraction. Right? If we want to switch over to Oracle, all we have to do is change the driver. No code changes over here at all. It all stays the same. Right? And it's only possible because of dependency inversion. Not relying on low-level objects like SQL or database drivers, instead relying on an interface. Yeah.
So the database is implemented interface. What does the project do to the interface? Does it call it?
Yeah, it calls it's like I want to load up assets from my asset table, right? You would write code over here that program towards the interface, get table contents. There is no such thing, but that's the idea, right? Get records from table. Right? So those are the solid principles, right? There's another. Where's my notes? Right, we'll call back to that later on. There's another 50-cent acronym if you're interested, right? Called the GRASP principles, right? These are really just restatements and then an expansion of the solid principles. General responsibility, something. Well, let's just open it. Come on. Oh, you're not a clickable link apparently. But I do have a web browser up here. General responsibility assignment software patterns. There we go. Or principles, right? And so there are 9 more principles that you can learn about. Some of them, again, they're just restatements of the 4 pillars and the 5 solid principles, right? In a different way of looking at them. But if you want to, you can read all about it there. I'm not going to go over all of them because, again, they're all just restatements of them. Right? So questions on object-oriented programming, design, stuff like that? No? Any questions online? Nope. Person is universal. Okay. All right. Then, let me go ahead and get rid of this. I think I'll keep this up here for a second. I think you can get rid of this though. Let me motivate. So that takes us to the end of this module, the object-oriented programming. I just want to get you started for next week with a motivating example and then getting you set up as well. So the motivating example here is going to be data very similar to the data that you've been looking at so far. You've been processing CSV files, right? CSV files are flat files. They've taken a data model and they've flattened it out. Right? Here's another similar flat file or a flattened data model. It's a course enrollment system. Right? We've got courses and the course name. We've got students, their NUIDs, and then their emails for contacting them through the course enrollment system. Right? Now take a good hard look at this data and tell me, do you see any anomalies? Do you see anything weird or bad? Yeah.
A course has multiple students?
Okay, so a course could have multiple students here. In 156, I've got Lou Reed and Tom Waits. Right? But what else do you notice about it? The first 2 columns. Repeat data of repeat data, repeat data, repeat data. Right? So repetition of data, bad. Why? Because it introduces the opportunity for data anomalies. For example, look at the student. Here we've got the student with 1, 2, 3, 4, 5, 6, 7, 8 NUID. We've got them 4 times. But look at their name. Is it universally represented? No, sometimes it's student, comma J. Sometimes it's student, comma John. Sometimes we've got Tom Waits all lowercase. Sometimes we've got Waits, comma Tom. Then we've got Tom Waits up here, right? Why does that first record exist in that first line? It doesn't. It's not even enrolled in any courses according to that line, right? It only exists because we've got this additional email over here, hotmail.com, right? Whereas, he's got two different emails here. Sometimes he has twaits@email.com. Sometimes he's got his Hotmail account here. Right? In fact, how do we represent that between the first record and the last record? An empty string versus none. Is that the same representation? No. An empty string versus null. Not the same representation. We've got data anomalies all over the place here, right? What are the bad problems here? Repetition of data, incomplete data, the integrity of data. Is an NUID a string or an integer? I don't know. If it were a flat file, is there a difference between an integer and a string? Nope, not enforceable. Everything is a string now in a flat file. Right? What about organizational problems? What if I wanted to formulate a roster just for 156? What would I have to do? I'd have to process the entire file. First record, second record, third record, right? 156, there's one. 156, there's another. 230, that's not it. So skip that record, go on to the next record. Right? I'd have to process the entire file all at once, which leads to concurrency issues. If one program or one thread is operating on a file at a time, it puts a lock on that file, right? Meaning that if I've got program A, B, and C all wanting to do something with this data, that means that program B has to wait for A to be done. Then C has to wait for B to be done, etc. I've got concurrency issues here. Imagine if, the classic example is, imagine if Google worked like that. If only ever one person in the world could use Google at one time. Right? And they had to wait for the other person to get done. No, that's not going to be operable. Updating information is also difficult because you have to go through and you have to find the one record that corresponds to what you want to change. For example, getting rid of the Hotmail address for Tom Waits. That's only one record, but you'd have to process every single record to find out that was the only record. Right? Formatting issues. Right? And concurrency issues. All of these problems are solved in a relational database management system, or RDBMS, or RDMS. Right? It depends on whether or not you consider database to be one word or two. Anybody? One word? Okay. But still, you don't say DAs. Those are district attorneys. You always say DBAs, database administrators. So it's one of those weird ones that, yeah, it's one word, but when you go to acronymize it, make it an acronym out of it, you want to DB, right?
Well, isn't like XML supposed to be start with E?
Yes, it's extensible markup language. And so, but EML, no, that sounds like a prog rock band, like ELO, right? Electric Light Orchestra, right? So anyway, it stores data not in single files. I mean, ultimately it's a file on the system, but it stores it conceptually in tables. Tables have rows, which are records, and columns, which are individual pieces of data. And you've got one table and another table, and you have relationships between them. As a preview, jumping down all the way to the end here, right? I don't use these notes. We'll make our own notes. Here is what that database looks like as that data looks like as a normalized database. I have a student table. I have a course table. I have what's called a join table in between them, so that this student is enrolled in that course. This course has these students over here. You have what's called a many-to-many relationship, because one student can have multiple courses. One course will have multiple students. And then I also store the email table off all over here, so I don't have repetition of data. This defines a one-to-many relation because a student can have multiple emails. In fact, as students at UNL, you have at least 3. Like your CSE email, your Huskers email, and you may or may not know it, but you have a UNL email. Right? But they make it so that these 2 forward to that one, so that you don't have to muck around with it. Right? It's your Huskers email is the default now. I have at least 1, 2, 3. Now I've got 4 or 5 emails, but I forward everything to Gmail and just deal with it there. Right? In any case, much prettier diagram of the same thing is what's called a ER diagram. Right? Now this is a different database. This is a video game database, but it's conceptually almost exactly the same thing. Right? In fact, this is the data that you processed on your first homework assignment. what we did was we took this model and we flattened it out and then let you deal with a flattened data model, and so that you later on will appreciate how much better a relational model is. Right? Okay. In our last few minutes here, let me get you started. The first step, then you're not going to need any of this until next week, Lab 7, and also when you start designing your database. But you will need you will need a database account. Right? So if you go to your account management, cse.unl.edu, you log in. Yep, I think that's it. Nope. Nope. Come on. I think I'm just mistyping it. Yeah, okay, I was fat fingering it there. Anyway, once you've gone in with your CSE credentials, go over to account settings, and I already have a MySQL account because I've been using it for 10 years now. You might have a different message here that says activate it. In any case, you can always come back here and reset your password by clicking this. And eventually it sends you an email message that says that you got your password. Yeah?
CSE.unl.edu directing me to computing.unl.
That's okay. Computing.unl.edu/account. I'm sure that that'll be the same too. It'll just go to yeah. Oh, wow. They need to fix that. So definitely go to cse.unl.edu/account. They don't have a forward on the computing.unl.edu. Right? So yes, make sure that you're forwarding to that. You can also check out your printer quota. What? They actually charged me for printing something. I don't know what they charged me for, but whatever. All right. Anyway, once you've got your account, right, you'll get an email with your password. I won't show my password here. I showed it in the. It's been randomly generated here. Come on. Sometimes it takes a while to forward, so I might have to, like I did this morning, I'm gonna have to go to the command line and get it. I won't show this though. I don't know. You might appreciate this. So let's go back 30 years. How did we do email 30 years ago? Pine. Ooh, nice green screen kind of interface here. There are all my emails, right? And there's my email. No, not nice looking at all, right? But Pine or Elm is what we used to use, right? And there's my password. The second thing I'm going to recommend that you do is you download MySQL Workbench. This is a product put out by Oracle. If you just do a Google search for it, MySQL Workbench. You can download. It is cross-platform. I believe it's written in Java. You can download it for whatever operating system that you have. It's okay. It's not the best, but you pay for the best, and this is free, right? So I'm going to go ahead and fire up MySQL Workbench here. I've already got it installed. It is also available on the lab computers. If you don't have your own, if you're out of commission for your lab, you can go down to the lab and use it. It'll look slightly different on your first run, but you can always add a new connection. Right? You can name it whatever, honors, right? Name it whatever you want. The host that's the local host. So if you want to run an SQL server on your own computer, you can. I wouldn't recommend doing it though. You'll want to connect to your CSE server, which is cse.unl.edu. Only the web page is computing.unl.edu. All our servers are still the same. Right? Do not change the port. That is the standard MySQL port. You are not root, however. You are you. I am me. Right. So whatever your login is, that's what's going to be your username. All right. You can test the connection if you want. Otherwise, you've created this. Go ahead and double click on it. Provide that password. Right? And now you're connected. Right? So let me go ahead and use my database. Oh, come on. There you go. Use your database. Your database, the name of your database is the same as your user login. Right? So me, it's Seaberg. Right? Go ahead and execute this. And now I'm using my database. What tables do I have in there right now? Show tables. Well, like you, none, because I haven't created any yet. That's where we'll start on Thursday, right? Yeah, Thursday. But I did want to show you the basic getting up and running with your database. If you want to, if you ever need to, wipe out your entire database. I did it this morning. That's why I don't have any tables. You can drop database, cvirk, right? And your database is now wiped out. There is no undo, right? So if you have test data or whatever, make sure that you're saving it in a DDL or a SQL file, right? You can always recreate it, create database. You can only ever create your own database. If I tried to create database foo, you see that red down there? I do not have permissions to arbitrarily create whatever database I want. You only have access to one database, the database named after your login. Now, you will have an albums database, a video game database, your project database. It is okay for these tables to live side by side in one database. If it were set up differently, or if this were a real server that you had complete control over, you could create as many databases as you want and separate them. There's an albums database over there. There's a video game database over there. There's a project database over there. We don't have that luxury here because that's the way they set it up. All right? So, kill your database, create your database, show your tables, but of course there are no tables. Right? And then you have to use your database once you've created it. Show tables, there are no tables. Right? So how do we create tables? What do you think? Create table, foo, right? And then I'll make it into an empty table here. I wonder if that works. Nope, you have to have something in there. Right? So create table, int bar, there we go, bar int, yeah, that's it. Nope, just that. There we go. Now show tables. I have to remind myself of the syntax. There's my foo table. It is case sensitive, so be careful. Yeah.
I can't log into my thing. It says wrong password or something.
Oh, I don't. Whatever your CSE password is.
Yeah, I just use it to log into CSE and it works. The one I used to log into web haven.
Yeah, that one. Yep.
I use that to log into my web haven. I can't do that for my.
I have no idea. Tell me your password and I'll help you.
So the server is supposed to be MySQL at csc.usl.edu.
No. What do you mean?
Because when you connect to the SQL server,
Right.
so and it shows that service. And then when it prompts you to enter in your password, it shows your user.
Whatever password they sent you through email, it is a different password.
Oh.
Again, the password that I was just sent was randomly generated. Nope, whatever this is. That was all just spam, I guess. Well, nope. Where was it? Thought I had it. Maybe I deleted it already, or whatever. Anyway, it's different passwords. In fact, password management, your database password should not be a password that you care about. Ultimately, if you're working with somebody, you will share that password. Ultimately, you will put that password into your Java code plain text unencrypted. So if you're using the same password as your bank account, not that we're going to go digging or anything, but the graders will see it, partners will see it, I can see it, right? Anybody with access to your code can see it. So use a password that you don't care about. Okay? Yeah.
So how do I generate the password for my database?
It should look something like go to account settings. Are you in this right now?
Yeah.
Account settings, and then somewhere on there should be a MySQL account.
Check it.
Click here to reset your password, and it'll send it to you. It should be automatic. It'll automatically be generated. It shouldn't take too long. It's an automated process.
Yeah, it doesn't say forgot password until you check the box.
Okay. I see. The interface. By the way, if you want to reset your password, once you use your database, you can go ahead and actually, before that even, you can set password equal to password. This will end up 1, 2, 3, 4. Right? That'll end up being your password. I just reset my password to 1, 2, 3, 4. All right. If you wanted to set it to something that you will remember, but again, not to something you care about because other people will see it. All right. Any questions? Otherwise, we'll pick it up there and we'll start on actual real database stuff here on Thursday. Oh, where's my OBS? All right, there we go.